Alright, so today we're talking about random variables. We'll start with the basic introduction of what a discrete random variable is and what a continuous random variable is. Alright, so first thing we need to know is that we have something called a probability model. And that probability model basically shows all possible probabilities for your outcomes. Alright, a random variable is just some variable that can happen in a chance process. Like, for instance, flipping a coin or rolling a die. In this example, we're flipping a coin 3 times, so our variable is going to be the number of heads that we get. Now, again, this is a random variable because we don't know how many heads we can get. We're just going to show all possible outcomes in our probability distribution model. So, for instance, there's 0 ways to get, or there's 1 way to get 0 heads. You can get tails, tails, tails. There's 3 ways to get 1 head. You can get heads, tails, 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 head, tails, or tails, tails, head. There's 3 ways to get 2 heads, 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 tails, heads, tails, heads, and tails, heads, heads. And there's 1 way to get 3 heads. So once we define like all the possible ways of getting those random variables, we can create our probability distribution model. So it shows that there's 8 total. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total possible ways to get heads. And so the possibility of getting 0 heads, or the probability of getting 0 heads, would be 1 out of 8, since there was 1 way to get 0 heads. Or the probability of getting 1 head would be 3 out of 8, since there was 3 ways to get 1 head, and so on. Now, once we create our model, once we get our nice pretty model, usually what we'll do is we'll graph it using a histogram generally, or a dot plot, to kind of describe the data a little bit better. Now we have 2 types of random variables. We have discrete random variables and we have continuous random variables. A discrete random variable basically takes on a fixed possible set of values. For instance, let's say the heads and tails thing, the ways of getting 3 heads. Well, you can only get 0 heads. If I flip the coin 3 times, I can only get 0 heads, 1 heads, 2 heads, or 3 heads. There's no possible way for me to get 1.5 heads, or 6.8 heads, or even 10 heads for that matter. There was a specific fixed set of values I could possibly get when I flipped that coin 3 times. Versus like a continuous random variable would be like the heights of all the girls in the class. Well, their heights could range. I don't know exactly what they are, but you could be 5'5", you could be 5'4", you could be 6'8". I mean, there's not a fixed set of values possible in that data set. Alright, so basically with your discrete random variables, we'll have all possible values of your variables. So that would be your x1, your x2, your x3, and then you'll have the probabilities of each one of those possible outcomes. Now you have to make sure again that you check that it's a legitimate probability model by making sure that all the probabilities are between 0 and 1, and that if you add up the probabilities, you get a sum of 1. Again, that has to be checked before you do anything with these random variables. You need to make sure that it's legitimate. Alright, so when you're analyzing your discrete random variables, you'll do the same thing that we did before. We're going right back to our SOCs. Remember, shape, center, outliers, and spreads. So you want to make sure that you're analyzing it properly. Remember, you can actually write down shape and write what it means, or you can write down center and then say what the center means. Now, generally with center, we really focus on, for our discrete random variables, we focus on using the mean and not the median. Alright, so our mean basically with our discrete random variables is our expected value, what you expect to get if you were to flip the coin, or what you expect to get if you were to roll the die. A lot of times you see expected value problems with carnival problems, like what's the chances that you'll win the prize. If you had to pay $1 and you could possibly win $5, what do you expect to win after you played it a whole bunch of times? Alright, so our formula for our mean is given below. This formula is on the formula sheet for the AP exam, but it's a very easy formula. Basically, you just take your x value. Let me see if I can show you. So I just simply take our x value, whatever that outcome is, multiply it by the probability. I take this outcome, multiply it by its probability, and then I take this outcome, multiply it by this probability. I keep going, multiplying my outcomes, my possible outcomes, by the probability. Once I get all of those products, I sum them together, and that will give you your expected value or your mean. Now, since we choose to use mean for discrete random variables, we need to make sure that we use standard deviation to analyze spread. Remember, mean and standard deviation go together. Median and interquartile range goes together. So again, since we're using mean, we're going to use standard deviation. Now, in order to find standard deviation, we have to find the variance first. If you remember, variance is the square of the standard deviation, or the standard deviation is a square root of the variance. All right, so to find your variance, again, if you have your data set, you have your values, you have the probabilities, so you're looking at your probability model. You find your variance by first finding the mean, then subtracting all of your possible outcomes, all of your x values minus your mean, and you square it, and then multiply it by the probability. That will give you your variance. Now remember, to get the square root of the standard deviation, you want to just take the square root of that variance. All right, so that was all on discrete random variables. We see that a lot when you're counting, like something could be 1, 2, 3, 4. There's no possibilities in between that or whatever. But sometimes you do run into situations that are called continuous random variables. And again, a continuous random variable takes on an interval in numbers. So there's an infinite possibility of outcomes that you could possibly get for x. Now the probability model, or the picture, for a discrete random variable is the histogram, but for a continuous random variable, it's your density curve. And we talked about that before. We see a pattern in our outcomes, and we just do a smooth curve on top of those patterns. Now again, you can still check for your probabilities being between 0 and 1. But you have to remember that you do have an infinite amount of possibilities, so it's really hard to check whether or not they add up to 1. And that's it.